Good evening, everyone. I'm Chise from Industrial Engineering Department, and my team members are Zeynep, Arda, Eray, and Seyit. Today, we are going to present our data sets, predictive maintenance. We got this data set from Kaggle, and it's a synthetic data set because real predictive maintenance data sets are generally difficult to obtain and also difficult to publish. We have a milling machine and its features. And instead of routine maintenance, we can try to predict if the machine needs maintenance or not. And by doing that, as we all know, the less production is interrupted, the more we gain from profit and time. And failure prediction can be used to pre-diagnose and fix the milling machines to prevent further maintenance and opportunity costs for out-of-service time.
My name is Eray. I'm from Information Systems Engineering Department. Our goal here is to predict whether a given machine is going to fail, and if it fails, what type of failure it will give. We will use supervised learning method because our data is labeled. And we are going to use the classification method because our target value is classified. Next, please. Our data has 10K samples, 13 features, 7 of them are categorical and 6 of them are numeric. Next, please. The machine failure rate is 3.39%. This is not an issue since it reflects real life values. If a machine fails too often, it cannot be used efficiently. So that's all.
Hi, everyone. My name is Zeynep, and I'm from Software Engineering Department. And in this data set, since it's a synthetic data set, fortunately, we don't have any missing data since it was made for this purpose specifically. Next, please. And here are a bunch of features. The UID is the identifier, which is the metadata essentially for this. And the product type, we have a low quality, medium, and high quality types of machines, which is also a factor in their failure rates. And the air temperature is the temperature of the surrounding environment, like the room temperature. And the process temperature is the temperature which is at the inside of the machine, that's basically when it's working. Next, please. And the rotation speed and torque are related to the part which is doing the milling, how much it spins and how much power it uses up. And the tool wear is how much this tool gets wear down by time, by usage, and it's given in minutes. And the previous quality measures I have talked about, these quality measures affect how much the tool wear will be actually. And we also have the machine failure label that indicates whether the machine has failed in terms of true or false, and also the types of machine failures, which will be explained later. And sorry, I need to check the amount. The amount of we call it numeric values is 6, if I'm not wrong, and 7 for the categorical. And the ones I explained here are the numerical ones, and the ones will be explained are going to be categorical. And you saw a milling machine over there, which helps to put the things into perspective a little bit. The smallest part that you can see over there is the part that's working in terms of tool wear. For me, at least.
My name is Arda. My department is computer engineering, and we have 5 failure modes in this data set. These failures usually occur due to certain machine features. First of all, we have tool wear failure. As the name suggests, it is related to tool wear. And then heat dissipation failure, which is regarding to the difference between air and process temperature and rotational speed. We have power failure is related to torque and rotational speeds, and overstrain failure is related to tool wear and torque. And also we have random failures, which means each process has a chance of 0.1% to fail regardless its process parameters. Next, please. In here, you can see all of our features and their statistics, their mean and max values, mean, mode, median, and dispersions. Also, you can see we don't have any missing data, 0%. Next, please. You can see there's a scatter plot example about tool wear failure. X-axis is tool wear and Y-axis is torque. And you can see where the tool wear failure are the red dots. When tool wear increase, tool wear failure begins to appear. Otherwise, it's not. Okay, next.
I'm Seyitcan Yılmaz from Computer Engineering Department. We have a graph here in x-axis tool wear in minutes and in y-axis torque in Newton meter. We have some blue points and red points. If they are red, we say that overstrain failure will be occurred, and if they are blue ones, it means there will be not fail the machine in overstrain failure. Next, please. And also we have another graph here, air temperature in x-axis in Kelvin, and in y-axis we have rotational speed in RPM. And again, here we can say that if they are red, it's heat dissipation failure, and if they are blue ones, they are no failure. And we can see that in red ones in a specific area, it will help us our machine learning model to predict if it is heat dissipation failure or not. Next, please. Again, we have another plot here. In x-axis, rotational speed in RPM, and in y-axis, torque in Newton meter. And in the max points of this graph, they can say that power failure will occur in its max points of these x and y axis values. Thank you very much.
Okay, thank you for the presentation. Can you go to the third slide, please? Yes. Here, in the third, 2 slides more, you have mentioned that there are 3% of failure samples, right? 3%.
Yeah.
Yes.
On fourth page, yeah.
It means that your data set is imbalance. Am I right?
Yeah.
So have you checked how to handle the imbalance data sets for classification?
I can't really say we checked it, but we thought that this data set synthetically created for this purpose. So there will be a way to use it, like as you said, to make the imbalance work with the data set.
But you have to take some precautions when you implement some machine learning models to solve or to predict the failure or not. Because when it is imbalanced data set, there will be some problems in prediction. So you need to read more about imbalanced data sets regarding to classification. Am I right?
Yeah, you are right.
So the second thing is that there are 5 failure modes. Am I right? 5 different failure modes.
Yes.
Yeah. Yeah.
Yes. So are you gonna consider these as just a failure, or do you consider this each of them a different failure type. And what you are gonna do with that? Are you gonna classify failure or non-failure? Or are you gonna classify both? So non-failure, power failure, torque failure, blah, blah. So it's gonna be binary classification problem or multi-class classification problem. Which one?
Hocam, we thought of multi-class because first you need to predict whether the machine is going to fail, and then you're going to predict the type. That's what we thought. So essentially, and it's kind of as if we're having two targets.
Well, what's your goal? It is not clearly written here, right?
And in the slide, yes, you're right. But we thought of making the failure modes. We thought of predicting the failure modes, which type of failure the machine is going to give.
Are you sure? Then
Yes.
it's gonna be much more imbalanced, right? Because
yes, Hocam, but I have something to say about this. We thought that we have 10K samples, and obviously around 300 something is the total number of failures.
yes.
And so first, by predicting whether the machine is going to fail or not, we're going to have a pool, and if it fails, we're going to have a pool of 300-ish samples.
Yes, but if you check the numbers,
and then from inside them, we're going to have the smaller amount. So there's going to be 100 tool wear failures, maybe 60 heat dissipation failures, etc. So I don't know, by doing a two-step thing, maybe we could,
I understand,
make it more balanced.
If you look at the train data or the whole data set, you will split train and test, right? For example, if you split train and test, for random failures, we have only 5 data points. And for example, tool wear failure, almost 70 samples. If you split these with the train, validation, and test data sets, they will not be enough, I believe. What do you think about it, Cise?
Hocam, I think when we split the data into this failure modes, we have enough data to predict whether the machine gives which failure modes. And actually we thought the data we have is enough for the predicts in this way, but I don't know.
Arda?
Actually, fails are certain machine features. If it's heat dissipations, we know its temperature and rotational speed. So I think we think we can.
If you argue that, if you really seriously argue that, then I would ask you why you are implementing machine learning. Why don't you just write a code with if-else structures, rule-based? If the temperature is greater than, then the machine fails. If you are serious about what you are saying, suggesting, then you don't need to implement the machine learning at all. Am I right?
Yeah,
so obvious.
Hocam, we can determine some areas with failure types, but in the last we can detect that it will be a failure or not. But classification will be binary, I think, because it's hard to find it will be tool wear or another failure type. Therefore, we should binary classification here. We should do.
Yes, maybe as you suggested, right? As suggested by Zeynep, you can do 2 phases classification. In the first case, apply the binary classification, checks that if you achieve a good level of accuracy, then maybe later you can try multi-class classification. In that type, there will be 6 classes, 5 of them some error mode, but one of them is the not error, but the class, this will be very imbalanced data because 97% of the time in the samples, there will be no failure. Am I right?
Yes, you're right.
So I think you will have some problem with that. Please read more about how to handle imbalanced data sets for binary and multi-class classification. Is that okay?
Yeah, we will do
Okay.
it.
Yes.
And the 2 slides more, please. Yes, here, did you check the find information projections here to see
Yeah,
the
we checked.
most
Yes, we checked.
related features as a regression or another metric? Have you checked it?
Hocam, in here, when we first do this, the most related ones are being the failure types together. So it's being a little bit, but yes, we checked it. So we were going one
Yeah.
by one within the informative projection.
Okay, so it means that you have a hope to classify successfully, right? According to these results, preliminary results. Am I right?
Yes, you're
hocam.
right.
Okay. So please
Yes.
just download the project final report template from Moodle and begin to fill in the template from today. Okay. Don't wait to the last day. So please download project report, final report, download it from Moodle and begin to fill in the required data information from that first presentation. All right?
Okay.
Okay.
Okay, thank you for your presentation. It's a good presentation, concise. So we will continue with the actually exploratory data analysis 2 weeks later. All right?
Okay.
Okay.
All right.
Thank you.
Okay, hocam.
Thank you.
Thank you for
Thank
your
you.
feedback.